All right, so we have just our basic circuit here with our two LEDs and two resistors. Our LEDs are sharing a ground, and that's just ran to the bus, ground, or negative back to the board, as shown in our other video. But what we're going to do here is now work on inputs, and what we're going to add to this is actually just a tiny little button. And in our little LED bag, we actually have a couple of these. And so these are just our tiny little button here, as you can see. And in this button, there are some lines, as you can see on the back side. And so these two terminals right here are always connected, as you can see by this line. And these two terminals on this side are always connected, as you can see by this line. And when this button is pressed, this side is connected to this side. So when I press this button down, it connects the terminals across this. So we're going to go ahead and wire up this button, and we're going to just end up putting it in a spot here that spans roughly 3 spots. Let's see if we can bring this up to you so you can see how I put that in there. And then I'm going to end up taking one lead and putting that lead of one side of this into digital pin 2 on the board. So let's unplug this so we're not going to short anything out here. But as you can see, one lead of that is going into pin 2 via that green line there, green wire. And then I'm going to grab the other side of that button, and I'm going to stick that right into the ground rail, somewhere over here. There we go. So as you can see, that other side is connected to ground. So now we have pin 2 going to button, button going to ground. So let's go in and let's end up coding something for this so that when we press this button, it sends a signal to pin 2, and then that also sends a signal out to the LEDs. So pin 2, we're taking a signal in, and then we're sending a signal out via pin 8 and 13. So let's go ahead and code that. All right, so we got the old sketch pulled up that we were working on before, but I'm going to actually just start with a new sketch here. So we have this pulled up. I'm going to hit enter a couple times here, get some space here. And I'm going to start with the comment section that I normally put out there. I think it's this, and then this will get you the large area. So anything in this 2 area, I can type in here, and it's grayed out for comment section. As you can tell, that's not. So I want to call this blink to LED with a button. And I guess today's date is 9/26/2025. And we can go on here and say notes, and we can say code. What's this code for? Code for 2 LEDs with a button. And then we can put in here what our pinouts might be, other notes we might want. And remember, we hooked that button up to, what was it, 2? Yeah. And so you can just put your basic notes up here. We can go File, Save As. We do a quick Save As here, and let's go button for now. Have that saved. So now it's just going to auto-save because we already have that set up in our preferences. So now we can go ahead and start. And the first thing we want to start with is that void setup. So this is, like we said again, this is only going to run once. And here we want to set up our serials, our pins. And so we want to set up our pinouts. So I'm going to put a couple enters there. And remember, your code just wants to be right inside these 2 little curly brackets. So let's start with our basic pins like we had before. So we go pin mode, and we had that first pin, which was pin 8. Actually, I'm going to teach you something here. Let's go back. Let's Control Z. Let's restart. Let's go back here. Before this, before even the pin setup, there's something we can do, and it's called establishing variables. And we kind of went over this a little bit in class maybe, but this is where I said int. Or I said float, right? And what this is looking for is when we're establishing a variable, it's very similar to like LED built in, where you would say integer, which is int, which is I want a solid number, and I want to call this solid number LED1. I'm going to name it LED1. I'm going to set that equal to 8 for pin 8, right? And so I can do this again. I can say int LED2 equals 13. So what's this saying is I want an integer. I want to call that integer LED1. I want to set that integer to a value of 8. So it's just saying what type it is and what its value. And we're naming it LED1. Same thing here. What type it is, what we name it, and that's just declared by just a space between int and that our name. And then we're setting it equal to a value, and we're closing it. And then we can also do this for the button. We can say int button. We can call that button. We say equal to 2, and we close it. So now when we actually go to establish our pin mode, we can say, instead of just putting numbers in those spots for declaring, hey, pin 8 output, pin 13 output, pin 2 input, we can just say pin LED output, pin LED output, pin button input. And so we can just go pin mode, and instead of putting that A here, we just start typing LED and it comes up. And so we just want to put that as LED1, and that's our pin 8. And so we can put that as an output. And we can close that. And then we can do this again, pin mode, because we have to do this for all of our pins. We can do LED2. And then we can also put that as an output. And then we have to, now we have this new pin, which we plugged it into pin 2, but now we call that button. We're going to establish that, and then we put that as we are putting data into pin 2. We are going to send data into pin 2 by saying button pressed, right? Pin 2. So that's an input. And we can close that. So okay, so now we've established our pinouts. We've established everything we need to do for setup, where it establishes our pinouts and says, hey, pin 8, pin 13, and pin 2, you are these things. You are an input, you are an output. We can move on to our actual code, what we actually want to code. So when we press this button, right, when we send data into the board, we want data to come out of the board. We want the pin 8 and 13 to send a signal to our LEDs to light up. So to start with that, we're going to start with something new. It's called if statements and else statements. And so what this is, these are loops essentially. Just like this loop that always constantly runs, it's another type of loop that we're going to put nest inside this loop. But what this is doing is let's just write it out and we can talk it through. So we can just start by typing if. And as you can see, it says condition and then statement. And the condition is if this condition is true or false, if this condition is met, then run the statement, run the code. That's all this is saying. So we can go tab and we have a condition. And so in this, we have that input. We have digital 2 reading in. And so we have to, instead of we were writing digital right before, now we want to say, hey, read in data. So we'd have to say, hey, if digital 2, there we go, digital read. So pin button equals, timeout, equals, what am I doing? Equals low, then run this statement inside this code, right? And so I'm going to give us some space here. So what it's saying is if digital pin 2 reads in a low equals low, run this code, right? And then after this code, if nothing happens, we could put an else statement. We want to put else statements after this. So I'm just going to put that right there. Else this, right? So go back up to the if statement. So if we read in low or low on digital pin 2, run this. And so what we want to do here is do the digital writes. We want to send data out to 13, send data out to 8. So what I'm going to do here is just like the code we did before, digital write, and I'm going to start with pin 8, so that's LED 1. I'm going to say hi, and then I'm going to close that. Tab. And so just to organize myself, I might hit enter. I might start this down here a little bit, and then I'm going to say delay for, I don't know, a second, right? Digital write, LED 1. Off, low, right? For half a second. Let's go back to that basic thing. So now we just wrote to digital pin 8, high, on, and then we wrote to it off. And now we want to actually do that same thing with, let's just copy and paste here, and we can click here, and we can say, change this out, right? And we just copy and paste this over, and now we want to do the same thing with LED 2. So we see to change these LED 2s to on and off here. So LED 2. And so we're digitally writing to pin 8 or digitally writing to LED 1 on, and then digitally writing to LED 1 off, and then digitally writing to LED 2 on, and then digitally writing to LED 2 off. And that's all that is. So if a button hits and we press that button, it's going to run this code. If the button is not pressed, we probably want to keep the lights off, right? And so then we probably just go here, give us some space in here so we can see what we're doing, tab this out just a little bit, and we're going to digitally write to LED 1, low. And we're going to close that. And we're going to do this again. We're going to digitally write to LED 2, low. And we're going to close that again. And so we don't have to put any delays here. We don't have to put any times here, because what we want this to do is if the button is pressed, we want it to run this code. If it's not pressed, else, anything else happens, just keep the LEDs off. And so we don't have to put any time. We just put keep LEDs off, right to it off, right to it off, right to it off. So what this does is this loop, this void loop, inside this void loop, so we have essentially 2 loops going on. We have this loop running and looking for the button press, looking for the button press. So the button press doesn't get pressed, it jumps down to the else and says, I'm just going to run this loop. I'm just going to run this loop. We don't want to do that. I just want to run this loop else and just keep running the else until it sees this. So it just systematically runs and says, no if, all right, else. No if, all right, else. Oh, I see the button has been pressed. Now run that code. So let's go over to our board, plug in our board, and upload that. So I'm going to bring that into the screen here. Okay, so we have the old code running on these 2 LEDs because we haven't uploaded the new one. We're going to go ahead and upload the new one. Just going to compile the sketch and upload it. All right, so like we have it stated, we don't have the button pressed, so it's running the else statement, saying digitally write low, low for both LEDs. but I already know there's going to be an issue with this. Maybe it'll show it. Yep. So it ran the code twice. And we press it again. It might run the code twice, might not. Ran the code twice, and it's kind of dimmer or slower on the next run through. That is because we set the pin to an input, and the input is high impedance. And so if you set a digital pin to an input, it's high impedance. What that means is that it's expecting a resistor here, or you probably should wire a resistor in. You don't have to, obviously, it doesn't matter. But the pin has capacitance in it. It's holding a charge. And so what the thing is running, it's running the full code. And let's bump these things down. You'll see it a lot more prevalent. It's only supposed to turn on pin 1 once, or LED once. LED 1 once and turn it off, and then turn on LED 2 once and turn it off, and then jump out and look for the button again. But it's running it twice. And if we jump this down and we say 50, 50, 100. So we'll make it a lot faster. We'll enter this up. You'll actually see this thing go crazy. So sometimes it's running the code really fast for twice. Sometimes it's going crazy. It's doing different weird things, right? And so do it again. See? Now it's just leaving the charge go. So it does crazy things right now. I think I just bumped the ground. Anyways, so that is because there's a leftover charge. And to solve that, there's an internal resistor we can actually use on the Arduino board rather than putting one on this input. And so it's called int pull up. Input pull up, not int pull up. It's input pull up. And what that does is uses this onboard resistor so that it eliminates that charge. So when I only press this once, it only runs once. We're not going to get anything crazy going. So that's essentially our circuit. That's essentially our code. We're just running some if statements. This loop is just running, looking for that button on the if statement. If it doesn't run it, it just keeps running this else statement and just keeps running that loop and says else, 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 else. Oh, button pressed if. Sorry, button pressed if. So that's your basic code. We did some establishments of some variables, and we're just going to move on here. So